Well, Edward, thank you for your kind words. Yes, and today we will have a session about working with edge and cloud in a very harsh condition, offshore condition, and we will see how we can add real-time intelligence on top of that. My name is Sander van der Velde. I'm a principal architect at the SDG group. And as Edward already mentioned, over the last 8 years I've been rewarded each year for my community contributions, presentations, blogging, workshops, honest feedback to the product groups from Microsoft regarding IoT and real-time intelligence. In my day job I'm working for the SDG group, which is a global consultancy firm doing AI, analytics, machine learning, data. And that's a perfect combination for me because we are part of the Alto group. And the Alto group is really a good global player regarding consultancy for high-tech companies. So I work together with colleagues in both worlds, both divisions, to bring IoT to life for customers. We have an office here in Barcelona. You obviously have seen that I'm not from Barcelona. I'm from the Netherlands because we're a global player. I have more than 2,000 colleagues and we are working for 700 plus customers. We will look at the use case of a customer, Sequelize, for offshore heave compensation, the challenges that we had to overcome, the solution that was built, and there's room for Q&A. So if you have some questions, please shout out. The reason I do IoT is one of the biggest reason is that I come at places I've never been. In this case, we see a picture taken in the harbor of Rotterdam. We see this big ship. It has a crane 100 meters high. It's used for lifting windmills in offshore conditions. So those big poles are actually like feet standing on the ground of the ocean. So it can lift itself up as an artificial island. And there was a hole next to it where this big monstrosity was staying. It's 10 meters high, and my customer asked me, can you connect this? Because that's mainly the questions that I get, can you connect this device? In this case, I had no clue what it did. And what turned out, it's a device to compensate waves. So if you have to load something from a ship, the ship will go up and down, which is unsafe because you can slam the load to the ship. And when there's a rough sea, you have to stop with loading and offloading stuff. So they have this machine which can extract and collapse in the same rhythm as the ship. And it can do that up to 1,100 tons, metric tons, which is the same weight of multiple Boeing 747s. It can do that for 50 hours because it's autonomous with batteries. It can go up to 3.5 meters, half a meter a second. They don't need more because then there are other problems if the waves are high. And it's cloud connected via Wi-Fi, 4G, and even with Starlink satellite connection. So the challenge was, can you get this connected in offshore conditions? Because we need the diagnostics from all the machinery in there. That's interesting. Network connectivity, internet connection. And by the way, expect high volume of data. 30 to 50 times a second, 2 kilobyte byte arrays. That's the stuff that we get. And by the way, there are 2 or 3 or maybe even more messages that you will expect. And that information has to be sent to the cloud. And well, of course, the customer wanted some dashboarding in the cloud, so they can look in the Netherlands what's happening for the coast of America. But they also want dashboarding locally. And by the way, it's a prototype, so also the message format will change, will be extended over time. It's not fixed yet. So the high-level architecture that we came up with was, well, we start with a piece of code running locally on this device. There's a little mainframe in it, and we call it a VM. So we can read data from all the motors and the gears via a PLC, an industrial device for running logic. And I said, well, let's start easy. Just try to get once every 10 seconds one message, sent to the cloud, store it in the database, and we have a near real-time dashboard that we at least know what's happening and we know that we have an end-to-end connection. Regarding the high volume data, let's batch it into files and send those files over to the cloud, and we unpack them because that's more efficient because we can compress them really well, and that makes it cheaper with the communication and more reliable. And last but not least, we wanted dashboards locally for the helmsman and for the train driver, because they want to know what the machine is doing. There's something hanging on that train 100 meters high, and they want to have a grasp of if it's working as expected. In this case, we were allowed to bring our own logic. Normally, customers decide which kind of hardware they have and what we have to connect with. They also bring their own cloud choice, like AWS or Google, or well, in this case, Microsoft Azure. But we were allowed to choose one, and for me, that's perfect because we already had 4 years of experience with it. This is 2021 that we started with this project. And it's like Lego for me. With all the pieces of resources in the cloud to the left. You can pick the stuff that you want for databases, for reporting, for working with events, and connect them. And the same goes for the cloud. For the edge. On the edge, we have a Docker solution, Docker containers, pieces of logic that we can also connect. So for us, working with the edge solution from Microsoft was a very good choice. We found out, and we actually knew already because we were experienced with connecting devices. So the edge device gives me a global gateway to the Azure cloud. So I have a secure outbound connection. Each device has its own registration, its own identity. So spoofing is quite hard. Well, the outbound connection I already mentioned. That means that the device has no inbound connection, so it's not hackable from the outside. It's not listening to any questions. It's making a connection, and over that connection, it can do two-way communication for sending telemetry and receiving commands. We also have zero-touch deployment of those containers, so we can send containers to the device, update them without being near the device. I don't have to sit on my bicycle or get in a car or in a plane to update them. It's done remotely. And with custom logic, all those pieces, the telemetry, the insights, and the actions for a local feedback loop, Docker containers, they act like Lego. They have these knobs like mailboxes for receiving messages or for sending messages. And I, as an OT engineer, I can connect the dots. And last but not least, the messages bound for the cloud are persisted as long as they are not sent to the cloud. So if the cloud connection breaks between the IoT hub in this case and the edge device, locally everything still runs, messages are received as long as you have space in your hard disk. And once the connection is there again, it's all offloaded. So there's maybe a delay, but at least we have all messages. So in a more detailed solution, this is the cloud part, the stuff that we do with all the Lego pieces in the cloud. We see that we have a very straightforward line from receiving the messages from the device in the cloud gateway, the IoT hub. The messages are seen and inspected as a stream and stored in a database, and in this case managed Grafana dashboarding is offered. Why managed Grafana? Because managed Grafana gives access via Entra-ID or Active Directory accounts. So we are in full control of who is seeing what data. Because we can inspect it, we can also look for alerts. So we can send messages to something called the Logic app. So we can either send an email with a message in Teams, or we can send it to a ticketing system. And regarding the slow-moving data, the batch data, the files with thousands of single entries in there, those are sent in a blob storage. They are picked up as a piece of logic, extracted, and sent to the same database. So we have full control of all the data that is coming in. On the edge device itself, it's just a device that can run Windows, or in our case, Ubuntu, Linux, with a runtime and Docker containers on top of it. We see three kinds of Docker containers. There's the green one, the Edge Hub, and the Blob Sync. Those are provided by Microsoft out of the box, and they give me the opportunity to either send messages as a stream, that's the once every 10-second message, or with a blob file synchronization, and if a file is cut in the middle because the connection is disrupted, when the connection is there again, the rest of the file will be sent, and not the whole file for a second time, which is really easy if you're sending files of say 10 megabytes. The blue parts are stuff that you can just download from the internet and put in your own environment. Those are open sourced in FluxDB as a timesheet database, and Grafana also locally for the local dashboarding, for the helmsman, the train driver. The yellow part is the stuff that we created ourselves. We had to ingest data over the UDP protocol because the customer was afraid that using a heavier protocol like OpenCUA would disrupt the functionality on the PLC. And that data is then either sent to the Influx database, or it's sent to the cloud, or it's put in a file for the diagnostics 30 times a second communication. But we needed one more thing, because we get 2 kilobytes long byte arrays. We needed a Rosetta Stone. Maybe you've heard of the Rosetta Stone? You have one at home, maybe? This is actually a physical stone. It's not in a museum, but it's found by the army of Napoleon. And on the same stone, it has the same message 3 times. In Demotic, in ancient Greek language, and also in hieroglyphs. And back then, it's 200 years ago, they had not a really good feeling about hieroglyphs, how to work with that language. But using this stone, well, they just could compare it, and it was the breakthrough in deciphering hieroglyphs. And that's what we needed what I needed from my customer. I asked them, well, I have this byte array, how should I work with this? So I asked him for a Rosetta Stone. So each message tree, we have a separate file, which is nothing more than just the explanation of a certain value, the the type of it is. So an integer is 16 bits long, and it has a starting point, byte 12 in this case, and at bit 0. So here we see booleans, which are only 1 bit. So they say, well, okay, on byte 24, the second byte, that's the one that you need to get that value. So with that, we were able to work with this kind of messages. And that's something like a file like 500 values in there. Large fast. 70 kilobytes in, for each message. And we store them all, we store everything. Because we found out with the compression of sending the files, we have an excellent compression of say 95%. And the customer has no clue of what data they actually want to know about. So they said, well, just get everything. And the same goes for the databases. We have enough storage room. Only when we start to complain about there's no space anymore, at that point we will cut off the history. But at this moment we're still collecting because we want to know stuff about seasonal influences. That's something for that you need years of information. And storage is not the main price. It's not the main cost factor. It's the value that we get over collecting data for years. That's what we want to do. So once we actually knew what we got and we could create some dashboarding. We see here a picture of the actual test because it's just a piece of metal that they put on a ship, and you see that black thingy hanging, which is 10-12 meters in height. So the crane is going up in roof. And this is a similar island which is also standing on poles and doesn't work because it's a prototype. So, well, we looked at the data that came in, at the representation in Grafana, and it does work. This is an actual picture from one of the tests. So they have the hook and the piece of metal hanging underneath it. And they're moving the hook up and down, the actual hook from the crane, and the machine is still turned off. So we see the red line and the yellow line going in sync up and down. And at some point they start the balanced heave compensation somewhere here, and you suddenly see that the red line is almost around 0. It's not moving up and down anymore. There's no sinus anymore. That means that the load is still at the same point while the hook of the crane goes up and down. So that, hey, this is really something that could work. This is quite a game changer because they now can extend the window of giving, for being able to move loads from ships. And safety is now much more present because the load is not going up and down for somebody on the ship. It's just hanging at the same side while the ship is going up and down. And actually, Sequelize has won a very prestigious prize with this. It's the Maritime Innovation Award. Of course, because of the construction, the new technologies that they use, the algorithms that they use, the increased window of loading and offloading, but also because they are one of the first solutions which are actually cloud connected, which is quite unprecedented in the offshore world. They are quite conservative. So without the communication and being able to do remote monitoring and also remote diagnostics, this could probably not have worked in this short of time. In 3 years building a completely new solution. So what actually happened was after they won the prize, they got questions from other vendors, other 2 vendors. Can we make use of the same network infrastructure? We want it. most of the other tool vendors, and on most ships there are multiple solutions next to each other, so if one breaks, the other one can pick it up. Conservative people, so if you bring in some innovative stuff, they always have a backup. They were still working with USB sticks and getting data with file exchange over email, but they got this. So what we now are offering, what we are working on, is a product called C-Link, which is basically what we've built, but on a central place in the ship, on the main ship. And all the tool vendors can send their data to that solution that we have, with a database, with dashboarding, and with a cloud connection. And the tool vendors can see the information and work with dashboarding on their own data. They don't see each other's data, of course, because we put it in different databases, and we give each tool vendor its own credentials, both locally, but also in the cloud. And with cloud, that means with managed Grafana, with Entra ID accounts, so it's highly secure. And well, we're quite successful here. There's something on the right, on the right, because it doesn't stop with this. The next step that we have, that we're working on right now, is that there's value in having data from ships which are not in the neighborhood. Until now we worked with data from a local ship. Now we want to have data from multiple ships. Actually, we even want to have data from ships which are still in the harbor. And while they are traveling towards the main train ship, we want to have data from that also. So what we do is that we have a tool called C Connect. And we collect the data and we try to send it to the main ship. So everybody can at the local dashboarding, and we also have the cloud dashboarding available. But if the ship is too far away, we switch over to using Starlink satellite connection. And we have a full history of what happened with the load during the traveling from the harbor towards the heaving island. So that's the story that we are working on right now. So after 4 years, we are expanding. So what I want to give you as a takeaway is, first of all, well, I think we have proven that we can do edge compute and IoT in offshore conditions. It's not really a proof of concept regarding can you connect a device. I still get those questions, but I rather think of proof of value. What's the value of the solution that we want to bring? And in this case, being able to collect diagnostics for further research, that's the stuff that they wanted to do. And then, yes, there's this big picture, and what if we connect everything in the whole world to this solution? Okay, that's a question that's really interesting, but maybe if you take the first step about take all your use cases, give them a priority, and only start with the first 2 of them, which are solvable and realistic, and give you a good grasp about what you need for the future, and be agile on it. Re-evaluate it if stuff will work or not. We also have, luckily, we made quite all the right choices, but we also have experimented with stuff. And I also have sometimes got a question about, I'm not sure if this will work. First do a little experiment and see what happens. And then last but not least, real-time intelligence and real-time insights is a game changer. I'm doing this already for 10 years, collecting data in real time and being able to represent it in dashboarding within starting to discover there's something called data which you can see in seconds, not in a batch running each night or each hour. So in industrial IoT, we see that the enterprise wants to know what's happening on the factory floor with the machines over there. And customers are also suddenly, enterprises, discovering that they already have real-time data, but they never looked at it. Because we are looking at the behavior, the messages coming from devices. But real-time data is about collecting data from humans, from colleagues, from workers, from customers. Either it's the logging in the databases from services, or the security audits, or it's data coming from shops, sales information, stockbroker information, financial information. That's all real-time stuff, and we are now seeing that companies and enterprises are turning to us. And the great part is, if you're doing IoT, you have a 10-year head start to the other markets. So with that, I want to complete my presentation. Thank you very much for attending. Please use the QR code. If you give a review, it helps me, it helps the organization. And I give it back to
Thank you. Thank you, Sander. Really appreciate the